Good morning, guys. We're starting hyperbolas today, so you need to have out worksheet 7, your reference sheet, your calculator, all that good stuff. Yes, 7. Good deal. Anybody else take the practice SAT this weekend? Had circles on it? Trig? Not much trig on the SAT, I don't think. Okay. All right. We're doing hyperbolas today. I've tried to give you applications of some of these conics as we went. The book has an application that says lightning detection systems use multiple sensors to digitize lightning strike waveforms and record details of the strike using extremely accurate GPS timing signals. 2 sensors detect a signal at slightly different times and generate a point on a hyperbola where the distance from each sensor is proportional to the difference in the time of arrival. We know that's different when you hear the thunder, right? It's proportional to how far away you are and that kind of thing. So these 2 sensors would take real-time data about that, and they would be able to determine exactly where the lightning strike occurred. Okay. Hyperbolas, I looked this up just today for you. What is the difference between a parabola and a hyperbola? And I didn't get a lot of really good answers, none of which were the ones I would have given you. But a parabola is when you cut your cone parallel to this side. Do you see how this plane is parallel to this side right here? Okay. Hyperbola is when you cut almost, it says almost, which is weird, perpendicular to the bases of the cone or parallel to the axis down the middle. I don't know why it couldn't be exactly perpendicular, but that's what one of the articles I read said. Here's a website that talked about the differences. At the very end here, it says, okay, if a point is equidistant from the directrix and the line that's the directrix, and equidistant from the focus, it's a parabola. We had that definition and we kind of went, okay, yeah, whatever. And when the difference of distances between a set of points points present in a plane to 2 fixed foci is a positive constant, it's called a hyperbola. So the definition is the distance between the points to the foci and the points on the hyperbola are a constant, okay? It says all parabolas are of the same shape, no matter what the size, and all hyperbolas are of different shapes. That didn't help me at all, because I don't think all parabolas are the same shape. When I think about narrow and skinny and wide, and that didn't make sense to me. All right, but back here, the big difference for us is going to be that hyperbolas have 2 branches. That seems pretty obvious difference, right? Okay, and I'll talk a little bit more as we go here. So this again, it says the absolute value of the difference of the distances from 2 foci is constant. This is just really confusing. You have 2 focus points, one inside each little piece that looks like a parabola, okay? If you take the distance from any point on the hyperbola to each of the foci and you subtract those differences, it's obviously further from one than it is from the other, then you would get a constant. Okay, nod, because I don't really get what that would do either. So, all right, our learning targets today, this is more important for us. I can graph a hyperbola from standard form stating the center, vertices, foci, and asymptotes. Those are the things you're going to have to know. I can complete the square to find the equation. I can write the equation given the vertices and foci, or given the vertices and equation of the asymptotes. All right, this is vocabulary that I think, if you look at your green sheets, is on there. I know it's on there, but It says transverse axis and conjugate axis on there. If we were drawing an ellipse, those would be the major and minor axis. Okay? So if we were drawing an ellipse in here, we'd have these two axes. The thing is, a transverse axis is going to actually go through the two hyperbolas, and the conjugate axis is going to go in between the two branches. I'm never going to ask you about them, other than that there might be a homework question that says something is twice as long as something else, and you can use this idea, okay? You can use your reference sheet, but it's not on a test or quiz. It's not vocabulary I have memorized, really. The auxiliary rectangle, on the other hand, is going to be really important, and you're going to be expected to draw this, okay? It's not actually a part of the hyperbola. It helps guide the hyperbola, just like the asymptotes. Okay, now you're like, what is she talking about? Okay, on your sheet, you're going to have to state the center, vertices, foci, and asymptotes. Those are the important things. All right, now let's get to what you actually need. What do you notice about this versus what we've been doing? It's the same thing as an ellipse, except it has a minus in the middle, okay? Now, the other thing is A is not always bigger than B. Does it say that on your green sheet? Look, A is the one that comes under the positive term in the front. Do you see how the minus is back here? So sometimes this first part has X and sometimes it has the Y. What's the difference? When the X is what's positive, it opens left and right. When the Y is what's positive and then it says a minus X quantity back here, then it opens up and down, okay? The thing is, A and B are not determined by size this time. A is always what's underneath the positive term, and it can be smaller than B. Let me give you a super quick example. When we had an ellipse, if we had a bigger A underneath the X, oh, we didn't get a rectangle. We got oval going that way, right? Today, we're going to get a rectangle, and we're going to draw the diagonals of the rectangle in. But once we've done that, we have to determine which one. If it had a positive X term, then it would open this way. If it had a positive Y term, it would open up and down. Let's just do an example. Okay, just watch me. This is a basic one whose center is at 0, 0. Everybody good? As there's no X minus H, Y minus K up there. In the Y direction, it's going to go 3. A is 3 because it's underneath the Y squared term that is positive. So in the Y direction, I'm going to go 3 this way and 3 this way. In the X direction, I'm going to go 5 from the center. So I'm going to go out to 5 this way and 5 this way. Now, we would have called this major axis and minor axis of an ellipse. But it's not determined. Whoa, what are we drawing here, Hofbauer? What it's actually determining for us today is this rectangle that we're going to draw, called the auxiliary rectangle, instead of drawing the ellipse. Because then what we're going to do is we're going to connect those corners this way to make the diagonals. They will always go through the center, okay? But the center is not actually part of our hyperbola, because the hyperbola is going to, because the Y was positive, the vertices are going to be here and here, which are the top and bottom of wherever that rectangle is. In this case, they're right on the Y-axis. And then it's going to open around the Y-axis like this. Now, when I draw this, this is what I think about as the difference between a parabola and a hyperbola. A parabola does not have asymptotes, right? It gets infinitely wider. This gets wider, but approaches this asymptote and can't ever pass that. Okay, and it has two branches, unlike a parabola. All right, the things you would need to tell me are the vertices, which were up here at 3 and -3. You would need to tell me the asymptotes. Now, I'm going to let you write the equations of asymptotes in y equals y point slope. Anybody remember point slope? Do you remember that form, guys? This one is really easy because they go through the origin. So you could write it in any form and get it. But all that's going to have, all of these asymptotes are going to have in common is that they go through the center. Now, rather than make you do a bunch of work, I'm just going to say, well, tell me it goes through the center, which will be here. This will be H and K. Make sense? All right. And then I'm going to tell you, you have to tell me the slope. Guys, what's the definition of slope? Change in y over change in x. How much did I go? Look underneath the y here. How much did I go either way? 3, which was a, right? How much did I go in the x direction? 5, which was the b. So it's going to be y minus 0, because it went through the origin, equals change in y over change in x is 3/5, and then x minus 0. Now, that means I went up 3 and over 5 or down 3 and over 5. That's where the plus or minus comes in. All right, last thing you have to do is find the foci. The foci now are going to be inside here somewhere and down here somewhere. Okay? They are further from the center than the vertex is. Make sense? So therefore, instead of a squared minus b squared, it's a squared plus b squared. So it says on your sheet, c squared equals a squared plus b squared. So we're going to do 9. Remember I told you before it was the opposite of the sign in the middle? So it's going to be 9 plus 25, which is what? 34. So square root of 34, which is almost 6. So this would be up at almost 6 and down at -6. Okay, is that what it has on your paper, guys? Yes? Does it even have that one? No, it doesn't even have this one, does it? Maybe, I don't know if it does, but we're going to do this one real fast. Which way would this one open? Up, down, or sideways? Up, down, because the y is positive. Okay, how far would I go up and down to find the vertices? 4 and -4. So the vertices are at 0 plus or minus 4. The center was at 0, 0 because it had no shifting on the top. It wasn't y minus anything besides 0 or k minus or x minus anything. Okay. How far does it go in the x direction? Yep, we take the square root of this, so it tells us to go 2. Now, we draw the rectangle that would go through those. So it would be bounded by x equals 2, x equals -2, y equals 4, and y equals -4. We draw in the diagonals, that's the word I'm trying to say. Now, if you don't draw the diagonals, are you going to be able, if you don't draw the rectangle, are you going to be able to draw those asymptotes very easily? You can use rulers from over by the calculators there, hanging on the wall if you want. All right. And where are the actual vertices? Well, they were up here at the top and down here at the bottom. So now you just want to draw a U shape in here, but it should be getting closer and closer to the asymptotes without touching. I'm a failure right there. Okay, I touched. Mine are definitely touching. Oh, it's just a hot mess. Okay, They should look the same. Mine look nothing. The one on the top looks nothing like the one on the bottom. But then we need to find the foci. To find the foci, we have to do, instead of a squared minus b squared, we have to go a squared plus b squared, and then square root. So we get square root of 20, which simplifies to what? 2 square roots of 5? Okay. Anybody? Square root of 20 is like 4.5, maybe? Anybody tell me what square root of 20 is? Okay, almost 4.5. So it would be just inside here, which we're going to learn the closer it is to the vertice, the narrower the shape, okay? This one was way far inside here, right? It was like the vertice was at 4 and this was at almost 6. Okay, so this was very wide. You don't have to know that. I'm just trying to give you a hint. Here, this foci is very close. It's at 0 plus or minus 2 square roots of 5. All right, what about the equations of those asymptotes? Well, they go through the center, which is what? 0, 0, right? Center of our... But anybody know what the slope is? Change in y over change in x. Okay, but remember, these were squared, so it actually went up how far? 4 and over 2, which is a over b. Okay, be careful because when it opens the other way, it's going to be b over a. So you have to do whatever's under the y goes on top, and whatever's under the x goes in the denominator. That reduces to 2, and we put a plus or minus. So you could have just written plus or minus 2x for these, but that's because they go through 0, 0. Okay, you can leave it in this form, though, as far as I'm concerned. All right, let's try one that doesn't go through 0, 0. Or not. Try one that does. What's different about this one? Yeah, this time we're going, what's A? A is 5, even though that's smaller than this, right? A is the one that comes under the positive term. B is 6. Anybody figure out C? How do we find C? Yes. So 5 squared plus B squared, which is 6 squared. Is that square root of 61? All right, so to graph this, I go 5 in the x direction. I go 6 in the y direction. I draw a rectangle. Which of those are the vertices, guys? The ones on the x-axis or y-axis? X, because the x was what was positive, so it was opening this way. So the vertices are at plus or minus 5, 0. Where are the foci at? Everybody know that? Plus or minus square root of 61, 0, which is almost 8, I think. Okay, almost 8. And the asymptotes, I'm just going to do the general form, y minus k equals, and over here we have x minus h. Now, it's sometimes a over b and sometimes b over a. It has to come from what's under the y goes on the top. Well, this is 6 squared, right? And this is 5 squared. So it's 6/5 and it's plus or minus. Does that match up with the idea? If I Went right here. Did we go up 6 and over 5 to get our rectangle? Okay. All right. Now let's try one that's not at the center. So you start out exactly like you're doing an ellipse, guys. Except you don't draw the curve, you draw a rectangle. So where do I start? Where's my center? Be careful, yeah. This one's evil from the beginning because this is y minus k, right? And x minus h. So maybe we need to start our little list over here. H is -2. K is +3. A is what? 5. B is 3. And we can get to C in a minute. All right, so the center is at HK, which is -2, +3. -2, +3. From there, how much do I go to the left and right? Left and right is, guys, under the X here, so I go 3, which those, are those the ones we're going to label as vertices in a minute? No, because the Y is first, it's the positive one, so we're going to actually open it up and down. All right, if we go 5 up and down, those are the vertices, okay? If you look at your sheet, when the y is the positive one, it says the vertices are at h, comma, k, plus or minus a, which is -2, comma, 3, plus or minus 5. Okay, if we go from here, up 5, 2, 4, 5, and down 5, 2, 4, 5, we get -2, 8, and -2, -2. Does that seem right to everybody? Draw your rectangle. Instead of the ellipse, you're drawing a rectangle. Then you're going to put in your asymptotes. Yes, I'm cheating. Okay. Your asymptotes should intersect where? At the center here. Okay. And then the actual hyperbolas, where am I going to draw? Top and bottom, right? Because the y was first, so up here. And down here. All right. So vertices I have. How do I do asymptotes? Okay, the formula when it opens up and down is y minus k equals plus or minus a over b, comma, x minus h. I don't ever use that. I use point slope. I know it goes through this center. So I go y minus 3 equals plus or minus. And then I just go back here. What was under the y and what was under the x? 25 and 9, but this was 5 squared and 3 squared. So it's going to be 5/3. X minus h, well, h was 2, so, and you can leave it in that form. You don't have to distribute once with the positive and once with the negative, and then move the 2, blah. I just realized how awkward that looks right there. Does that not have any symmetry whatsoever when I drew it? Okay, we need the foci. That's the part we didn't do yet. So we have to find c. C squared is a squared plus b squared, or 25 plus 9, which is 34. So c is the square root of 34. But it's up here, 2, 4, almost 6. Inside of here, there's a focus there and one down here. Okay? So we added and subtracted onto what in the case of this, when it's opening up and down? We're going to add and subtract it onto the y, or here the 3. And that's all on your sheet. It says the focus is at h, comma, k plus or minus c. There's going to be negative 2, comma 3 plus or minus square root of 34. And since that's ugly decimal, we can leave it that way. Yes. All right. Who's got a question? Nobody yet? All right, let's try this one. Let's write down, because some of you need a recipe. Write down the recipe. What is h? Remember, h is always in with the x, so it's 1. In with the y is the k. K is what? Negative 2. Now, how do I determine a and b? Yeah, there's a minus in here, so the one under that's not following the negative, okay, this is the a squared, so a is going to be 4, and b is going to be 6. This is b squared. While we're at it, shall we do c? C is the square root of a squared plus b squared, which is 16 plus 36, which is 52. Which is what? 4 times 13. So plus or minus 2 square roots of 13. Yuck. What was the decimal? About 7.2 units away. You should reduce the radical. It's probably the least of my concerns on the actual quiz. I don't think that's going to be an error. All right. So how do I draw this? Where do I start? Center, yes. 1, negative 2. Good job. Positive 1, negative 2. Okay. Then what? Okay. Left and right 4. So 1 plus or minus 4, comma negative 2. Is that the recipe for the vertices, guys? Vertices, when it's opening sideways, it says h plus or minus a, comma k. Did we do that right? 1 plus or minus 4. Okay. So we would have for the vertices 5, negative 2, and what's the other one? Negative 3, negative 2. Went this way, 2, 4 would be 5, and this way, 2, 4 would be negative 3. All right. We don't have a name for the other ends of our rectangles, but how much are we going up and down? We're going 6, so 2, 4, 6. 2, 4, 6. Draw our rectangle. Draw our asymptotes. Really important that they go through the center. And then which way am I drawing this one? Yeah, the vertices were over here. They are actually on the rectangle, okay? And then it's opening left and right, and those would get closer and closer to the asymptotes out here. All right. So it says for the focus, when it's opening sideways, I'm supposed to do h plus or minus c, comma k. So we can leave those how? We got that? 1 plus or minus 2 square roots of 13, or even square root of 52, comma k, which is negative 2. So if this was 1 plus 7.2, 8.2, they'd be 1 at 8.2. And 1 minus 7.2 would be like at negative 6.2. Asymptotes? Y minus negative 2, or y plus 2, right? So this right up here, y plus 2, equals, and back here it's going to go x minus 1, or x minus h. And in here goes the slope, plus or minus, but it's change in y over change in x. So is it a over b or b over a this time? It's b over a, and it says it right on the sheet. But be careful. 6 over 4 is what? Reduces to 3 over 2. And you should reduce the slope. I'm not making you do any other distributing or simplifying, but you can reduce the slope. Oh yeah, thanks. I didn't put that in there. Good call. This should be x minus 1. Thanks. Any questions? All right, does anybody remember the definition of eccentricity? E equals C over A. Okay, C is the distance out. Look at my picture here. Let me use my highlighter. C is the distance out to the focus, and A is the distance out to the vertex. Which is going to be bigger on this picture always? C. So if C is bigger than A, when I put C over A, I'm going to get a number greater than 1, right? Greater than 1. All right. So we're going to talk about eccentricity. It says, when converting from general form to standard form, always remember the difference of the two algebraic terms must be equal to 1. We know that, right? It's got to be equal 1 on the right side. Okay, if it's a sum in the middle, it's an ellipse or a circle, right? If it's going exactly the same in either direction, it's a circle. If it's a difference in the middle of the two quantities, it's a hyperbola. What would make it a parabola? If they're not both squared, if one of them's squared and the other one's not, right? Then it's a parabola. All right, so we're supposed to identify the conic. You have this, number 16? I don't know if it's numbered. Is that what it is? Okay, I'm going to rearrange, put the x squareds together, and the 4x and a blank, and then a y squared plus 6y and a blank equals negative 4 and a couple blanks. Okay, anybody want to complete the square? X minus 2 squared with a plus 4. Okay, what about this one? Somebody? Squared with a 9. So what's on the right side? Negative 4 plus 9 is just 9. Now, if you want it in the form, you can leave it in this form as far as I'm concerned because I can tell what it is now. If you divided those all by 9 so that you had a 1 over here because they say it should always equal 1, I don't care. But how do you know that that's a circle and not an ellipse? It's got a plus, so it's either a circle or an ellipse. Both are squared, so it's not parabola. But it went 3 each way and 3 each way up and down and sideways, right? So it would be a circle. You could have left it in the form we had with x minus 2 squared plus y plus 3 squared equals 9, and this is r squared, right? So it's a circle whose radius is 3 and whose center is at 2, negative 3. Eccentricity. Right, eccentricity of a circle. Remember, how far apart are the two pieces of tape when I make a circle? 0 distance. All right, let's complete the square on this mess over here. We have a 9. What do we want to do with that 9? Well, eventually, but we're going to factor it out. So we have x squared plus, what am I taking it out of here? 54, right? Which would be 6x plus blank. What? Oops, there's no squared there. Okay. What am I taking out of the y's? 4 parenthesis y squared plus 2y plus blank equals negative 49, yep, plus a couple blanks. All right, so I have 9. X plus half of this is 3 squared is 9. What do I have to be super careful of on the other side, though? 9 times 9 goes over there. Okay, plus 4, y plus half of 2 is 1. Squared is 1, but that's 4 times 1 right up there. All right, so over here I have negative 49 plus 9 times 9 plus 4 times 1, which would be 81, and 4 is 85. Is it 36? I'm just guessing. It's got to be something, right, that 4 and 9 will go into for our sake, because we don't have ugly ones we have to do. Anybody get it? Is it exactly 36? We're good? Okay. Now, I'm down to knowing, because it has squared and a plus in the middle, it's a circle or a hyperbola. I'm pretty sure because there's a 9 and a 4, it's not going the same in both directions, right? 9 goes into 36 4 times, 4 goes into 36 9 times. So I end up with x plus 3 over 4, y plus 1 squared over 9 equals 1. It's an ellipse whose center is at what? Negative 3, negative 1. Is it longer up and down or across? Yes. A is actually 3 and B is 2, right? Because the definition for an ellipse is A is the bigger one. Okay, and it goes change in, it's longer underneath the Y, bigger number. All right, how do we find eccentricity on this, though, since we did this problem? E equals C over A. Well, what's A? If it's an ellipse, A squared is 9. Yep. So A is 3. How do we find C? Do you remember for an ellipse? The opposite of what it's doing in here. Yeah, so it's 9 minus 4, or square root of 5. So C over A is square root of 5 over 3. Can someone give me a decimal? What's square root of 5 divided by 3? 0.75 roughly? Okay, is that make sense? Do you remember? I know you don't remember, but if you look on the back, remember it says right here, ellipse has to have an eccentricity between 0 and 1, right? Okay. 18. Try this one on your own. Somebody check me because I'm not using a calculator. Or is it 12? Okay, so I got 25 times 36, that's a big number. This one's 900. So I'm at 9 so far. So did I get 25? Then if I divide everything by 25, ellipse or hyperbola? What did I do wrong? 25 over 25, that one should be 1 right there. Okay. Eccentricity would be C over A. What's A? A is not 1. Remember, for an ellipse, A is always the bigger number. This is B squared and this is A squared. So A is 5. How do I find C? Take those two squared numbers and do the opposite of this. 25 minus 1, which is square root of 24, or 2 square roots of 6. This should be less than 1, though. All right, let's do this one. I should have skipped that one and done this one with you because this is going to turn out to be 96 divided by 16 is 6. What are you taking out back here on the y's, though? This is the new. You got to take out a -1. So that becomes y squared minus 8y plus blank. Okay. Going quick. This is x minus 3 squared. 16 times 9, somebody? Or here, just do this whole side for me. -1, y minus 4 squared is 16, minus 16. 144 minus 128 is 16. So then if we divide everything by 16, okay, you get a hyperbola. Here's the problems you should be working on tonight. There's only 6 of them, guys. You can do it. Okay. And where'd you put your quiz? Oh, that's it. Right there. Thank you.